lecture guest. Today we'll have a couple of our colleagues from Japan and one from Taiwan. Let's start it with we invited Dr. Long, Candice Long, to give us an open remark. Please, Candice, your turn.
Dear participants and lecturers and co-organizers, good day. I'm Candice Long, the Deputy Director of the Research Center for Environmental Changes and the Deputy Executive Secretary of the Center for Sustainability Science of Academia Sinica. On behalf of the Academia Sinica, I'm happy to welcome all of you to attend this 2021 Advanced Institute on Knowledge-Based Actions. Academia Sinica is a national academy with 3 divisions, physical science, biological science, and humidity and social sciences, with particular emphasis on multidisciplinary and transdisciplinary collaboration. Academia Sinica not only emphasizes in basic research, but also value the contribution of applying scientific findings to enhance the resilience of our society. Programs of IRDR ICOE Taipei to promote integrated research for disaster risk reduction, DRR, including both natural and social sciences. The objective of this online AI is to provide participants with the best practice, enhanced understanding, skills, and practical knowledge to apply online synthesis system, OSS, and facilitators approach focus on DRR. This OSS for sustainability and resilience is a web-based knowledge integrated system. Facilitators are designed to use OSS knowledge on site to solve stakeholders' problems as a means of enhancing resilience. We would like to share these important systems and approaches with you to advance your daily work in reducing disaster risk. We are happy that 55 participants from more than 15 countries have registered for this AI, including senior researchers, practitioners, and students. We believe that the knowledge you are about to learn in this AI will make concrete and practical contribution to application and policies in your country. Following this 4-day training, there will be competitive seed grants to support the participants to apply these methods on the ground and solve important DRR issues you are facing to enhance resilience against disasters. Your active engagement will play an important role in promoting DRR in this world. I would like to thank our co-organizers, IRDR ICOE Japan, NCDR, and NIED for organizing this AI. And I would like to especially thank Professor Hayashi, the head of NIED, and Dr. Wilson Lee, the Secretary General of NCDR, for their continuous efforts. We all know how difficult it is to coordinate DRR training like this, especially under the influence of COVID-19. Finally, I hope that you can all benefit from the training program and build online friendship with internet interactions. I wish you the best. Thank you very much.
Thanks, Candice. Thank you very much. So, Yingquan, how you want us to proceed? I will talk as a ICOE Taipei, or you want to as a facilitator in the meeting?
Can you hear me?
Yeah.
For next, we would like to invite Dr. Hayashi to give us some words to welcome all the participants.
Okay. Good evening, or I should say good day. My name is Haruo Hayashi from National Research Institute for Science and Disaster Resilience. Very lengthy name. So we usually use NIED for short. And it is my great pleasure to be joining this AI KBA 2021. And especially this workshop will be focusing on online synthesis system and facilitator, how we use the facilitators using online synthesis system. And this is the work in progress made by mainly IRDL Japan National Committee for the last 5 years, since the 2015, when we had the Sendai UN conference. At that time, we discussed that it is important to have nation census reporting system. And then since that Asian region has very, very disaster prone, and many people are living here, and then highly economically developing region. So many of the natural disasters occurring here. So it is important to reflect our reality and our findings or our perspective to promote disaster risk reduction research and practices. So we wanted to have some kind of information integration assistance system using our own language. And then we keep discussing these issues for many years. And last year, we came up with a recommendation from Science Council of Japan, which hosts the IRD of Japan National Committee. And then ICOE Taipei and NCDR showed very great interest in this concept. And then we end up with this workshop. And then since COVID-19 still kind of prevent us from freely traveling around, so we have to make a use of online. And then in order to make us easier to concentrate on this workshop, we divided our workshop into 4 different days, 7th, 9th, and 14th and 16th. So each session will be about 3 hours. And we hope to look back the history of online system on the first day. On the second day, we will elaborate what will be the online census system. On the day 3, we will focus on other concepts of facilitators. And on the last day, we will have a free discussion with the participant for the SEEDS grant that some of you will get. And then we really hope that this SEEDS grant will be used for the promotion of online census system. This is a kind of idea we have, for this workshop, and then I hope this workshop will be very, very successful, and then provide you some kind of insights or information or chance for further work. And then I really appreciate that all of your participation. Thank you very much for your concern or interest. Thank you.
Thank you.
Yes.
Ying-Chen, please.
Thank you.
Hmm?
Should I
Thank
keep on
you.
talking?
Thank you, Professor Hayashi, Haruo
Okay.
Hayashi. And we would love to invite the General Secretary, Dr. Wei-Sen Lee of NCDR to also give us some words. Dr. Lee.
Colleague, good evening, colleagues of the Japan, Taiwan, and the Asia partner, and good day to all the other partners around the world. Today, on behalf of the NCDR, I am so honored to appreciate the chance that ICOE Taipei, Economic Syndicat, NIED, and ICOE Japan to co-host this workshop. I know this workshop from the name is very hard to understand immediately. As mentioned by Professor Hayashi, I start knowing the concept since 2015, but at the beginning, it took me a while to understand the true spirit of OSS and facilitator. And after years knowing the concept, I think OSS is kind of a milestone in this century in disaster risk management. Why? Because I think OSS and facilitator summarize all efforts of last 30 years and create a new paradigm to include all stakeholders in our society to work on disaster risk management, because it emphasizes cross-boundary and cross-language sharing and learning process. And I think all participants, including myself, we are so lucky in the coming 2 weeks because we have superstar from Japan and Taiwan to brief their experience and share knowledge about OSS. I think you can see today we had 3 superstars from Japan and 1 superstar from Taiwan. Their experience, I think, will give a very good beginning of OSS. Like Professor Xie Shangxian on behalf of Taiwan, she will give about how national synthesis in Taiwan to promote scientific investment in disaster risk management. Later, we have the Dr. Shi Xingyi, also from Taiwan. He's one of the very prominent cross-cutting medical doctor. He tried to combine mass medical demand with emergency operation and response. And myself will brief about NCDR role and function to synergize, partner, and facilitate DRR for disaster resilience. And I think, as mentioned by Professor Hayashi, though COVID-19 reduced our physical meeting, but never stopped our hands-in-hand collaboration. After 2-week workshop, we can find more space to work together, and I think we can make it. So thank you very much, and thank for all participation by everyone from today to next week. Thank you.
So, thank you, Dr. Lee. You're very brilliant in introduction to this workshop. And the next, we would like to that Dr. Hayashi has already provided a very big picture about the workshop. Do you still want to explain? Oh, I'm sorry. May we have? Can we all turn on the camera that we can have a group photo together?
Oh, okay. Yes.
Good idea.
Sorry, I almost forgot this step.
Yeah, I forgot something to say also.
No worry, we still have time for you. 可以了吗？ 可以开始了吗？ Okay, 1, 2, 3. And 1, 2, 3. Okay, let's have one more. 1, 2, 3. Okay, thank you. Thank you.
Thank you.
And so, still, we would like to invite Dr. Hayashi to give us more detail about the OSS and facilitator so that we can have a better sense about the whole picture. Dr. Hayashi.
Oh yeah, I think I've already mentioned that the big picture of the workshop, and then it is the things I wanted to say was I really thank the ICOE Taipei on behalf of ICOE Japan. ICOE Japan has newest ICOE under the IRDR group. We are the number 18 ICOE, and the ICOE Taipei is the number 1 ICOE under the IRDR program. And then we formally accepted last month. And this is our first activity as ICOE Japan. And then our ICOE have been aiming at promoting coherence among disaster risk reduction and climate change adaptation and sustainable development. And these 3 domains are very, very vast. And then probably nobody can master all of these domains, which suggests we need some kind of a tool to help us to familiarize ourselves to a relatively unfamiliarized domain to promote coherence. In my case, I spent more than 30 years in studying natural disaster risk reduction and some disaster reduction due to technological or biological hazard. But I'm not so familiar with climate change adaptation. So it is very difficult for me since I'm too old to study hard the new disciplines. And then, but I do feel I need to familiarize myself with these new disciplines. So I do need some good mentor to me to guide me to understand the new field. But unfortunately, it is very difficult for us to have that kind of a real mentor. But thanks to development of information and communication technologies, so we could have internet now. That's a very, very easy and very competent tool for us to get to know the things we want to know almost immediately. And then we thought that the power of internet can be utilized for us to promote the coherence among disaster risk reduction, climate change adaptation, and sustainable development. So, and then I do hate to, this is a very personal statement, I do hate to use English because I always feel incompetent in using this peculiar language. But I cannot speak French, I cannot speak German, I cannot speak Spanish, and then I'm sorry, I can't speak Chinese either. So the only way that I can use as a communicating with friends from a different country, I have to rely on English. But still, almost always gave me a kind of a dissatisfaction in communicating with others in English. So I've been hoping to use the Japanese as much as possible in communicating with new issues, new disciplines, and new people. And then again, thanks to internet, it is not the perfect, but they do have very good translation of one language to another. And by using that function, we may be able to communicate with the very different kind of people we never ever knew before the internet come into the world. So it is a kind of idea. Let's make use of the internet as the basis to promote the interdisciplinary and transdisciplinary research and practice on the coherence among disaster risk reduction, climate change adaptation, and sustainable development. That was a kind of a real impetus for us to promote the idea of online synthesis system. And then for the next 2 weeks, we are trying to introduce how far we came for the last 5 years, and then what we are now, and what we are hoping to go in the near future. And then and then all the lecturers from Japan side as related with a voluntary association called JHOP. This is the virtual alliance of the 15 disaster-related institutions. Most of them are universities. Like Professor Takara, he will speak this evening. He is from Kyoto University. And we'll have Professor Kawasaki, also from University of Tokyo, and Professor Tamura from Niigata University, and Professor Inoguchi from Toyama University. And these are the members of JHOP. And then we also have members, the National Research Institute. Professor Koike, he will speak this evening from ICHEM, from we call Doken. I'm not so sure what the proper.
Yeah, right.
Yeah. Anyhow, but and then like NID, he's also worked for the National Research Institute, and then Dr. Suzuki, also from NID, will be speaking this evening. So and then we have Japan Bosai platform. This is the platform consists of private companies interested in Bosai. Disaster risk reduction. These 15 institutions get together and to promote the ICOE Japan coherence. And then, so all of the members from JHOP will be hopefully enjoying the lectures for the next 2 weeks. And then it might be a very good chance for us to learn about the online synthesis system and facilitators in a very broad perspective. Thank you very much.
So thank you, Dr. Hayashi, for this very, very heartful introduction to the whole idea in your mind. And we really, ICOE Taipei really hope we can support the whole project to have a very valuable development. And because we have limited time, I'm thinking that originally we planned to have some introduction of the Sea Grant, but I think the introduction of the Sea Grant, we can actually move it to the last day because we have more flexibility then. And so the point here is that we wish all the participants, all the trainees can really get involved into this workshop. And so I think the involvement or the engagement to this workshop might be, have some benefit, helping them to apply for this Sea Grant. Okay, so thank you. And would you like to have some words, Dr. Jensen Lee?
Well, not exactly. So I just still want to say thank you for all, especially the Japanese team led by Hayashi-san and the some guests invited by recently. And I hope this collaboration between Japan, Taiwan, and the new ICOE between Japan and Taiwan could establish a good relationship, and really use this particular platform to encourage people, especially the young people, to work together. I think that's our the goal to do that. Okay, so it's a good start. Okay.
Yes.
Yeah.
Okay. So I think it's time for us to move to the next topic here. And do you want to have the microphone, Dr. Hayashi, or do you want me to introduce to the next topic?
Yeah, please go ahead.
Oh, okay. So for our next topic here is that we are going to welcome Dr. Kaoru Takada-san to give us an overview about why OSS/ASR and facilitator is needed. Please, Dr. Takada.
Thank you, Madam. May I share my slides? I'm trying to share my slides, but I cannot show you. Just a minute. System queues. Okay. I don't know how to.
Do you want me to play your slides from my computer? and you can ask me to go to next one.
Yeah.
Okay. So please do it. Thank you.
Okay. 这样有清楚吗？这样
Yes.
Looks fine.
Can you hear me? And can you see the slides?
Yes.
Yes.
Okay. So my talk today is entitled as Overview, Why OSSSR Facilitator is Necessary. This theme was given to me. My name is Kaoru Takara. I am a professor of Kyoto University Graduate School of Advanced Integrated Studies in Human Survivability and UNESCO Chair Wendy. And the next, please. My talk's aim is a detailed justification of why OSS facilitator is needed, providing historical background in terms of science for society and interdisciplinary or transdisciplinary. Next, please. I borrowed some sentences from handbook. The Sendai framework emphasizes the strengthening of dialogues between disaster risk reduction scientists, stakeholders, practitioners, and policymakers for real-world implementations. To facilitate dialogue and produce knowledge-based actions, disaster risk reduction in practice involves using both systems thinking and systems approach utilized to identify the interactions between science and practice. The online synthesis system, OSS, for sustainability and resilience is a web-based knowledge integration system. Facilitators are designed to use OSS knowledge on site to solve a stakeholders' problems as a means of strengthening resilience. The system should be promoted under interdisciplinary cooperation with international scientific organizations, various on-site stakeholders, and UN international agencies would be able to support enhancement of synthesis for strengthening disaster resilience and promoting sustainable development. So these sentences are borrowed from AIKBA 2021 handbook. And next, please. Next page, please. So this chart shows a kind of history of disaster risk reductions. After several UN discussions and resolution, in 1990s, there was a decadal international research project scientific program, which was called IDNDR, which stands for International Decade for Natural Disaster Reduction. And during this decade, there was a first conference on disaster reduction in Yokohama. Japanese government hosted it. But immediately after it, the Kobe earthquake took place. And IDNDR was succeeded by UNISDR, United Nations International Strategy for Disaster Reduction. And the UNISDR and Japanese government hosted a Second World Conference on Disaster Reduction in Kobe in 2005, 10 years after 1995 Kobe earthquake. And at that time, Hyogo Framework for Action was adopted, which is called HFA. And the HFA continued 2005 to 2015. During this decade, integrated research on disaster risk was established in 2008. And in the year 2015, there was a conference, UN conference, the third World Conference on Disaster Risk Reduction in Sendai, which was 4 years after the Tohoku earthquake and tsunami in 2011. And in Sendai Conference, a Sendai Framework for Disaster Risk Reduction was adopted. At the same time, in the same year, Sustainable Development Goals and Paris Agreement were agreed by the conference participants. And next year, a new urban agenda was adopted, which is also called as a Quito Declaration. Next, please. So with this history, recent global agenda, Education for Sustainable Development, ESD, and Sendai Framework, and SDGs, and Paris Agreement, and New Urban Agenda. Next, please. This slide also shows the time horizon since 2008, when IRDR was established. And immediately after that, in the year 2009, Japanese people who established Japan IRDR National Committee. And in the year 2015, there was a remarkable Tokyo conference which agreed Tokyo Statement or something like that, and the Tokyo conference output was inputted to UN World Conference on Disaster Risk Reduction in Sendai, 2015. Then 2017 Global Forum was held in Tokyo, and at that time many people got together from all over the world, and Japanese colleagues are also participating in this Global Forum in Tokyo. And there was a kind of framework how a national disaster reduction body behave in cooperation with many other partners or stakeholders or international organizations, as shown in the left bottom panel chart. And after that, in the year 2019, March, the Japanese hub for disaster risk reduction was established with more than 10 organizations' participation. And in the year 2021, we proposed ICOE Japan, and as Professor Hayashi mentioned last month, it was officially approved. So this is a short history of the Japanese colleagues or national committees of IRDR. Next, please. So this is the well-known Sustainable Development Goals icons. Next, please. And I already introduced Sendai Framework and SDGs, Paris Agreement, New Urban Agenda, and the Japanese Science Council committee. One of the committee of Science Council of Japan, which was led by Professor Koike, concluded a recommendation document, and it said recent discussions call for the promotion of these international challenges in an integrated manner under the expectation of strengthening disaster resilience to reduce impacts of disaster, overcome loss and damage, and recover as the prerequisites for achieving sustainable development. Based on the understanding that the above-mentioned challenges derived from different background and standpoints, there is a need to propose ideal views, support social implementation, improve better understanding based on practical experience, and develop an intellectual cyclic system. In this cycle, large expectations are laid for science. Next, please. And it is often said nowadays, science for society. And these paragraphs are taken from the UNESCO website. UNESCO is saying something about science for society. But unfortunately, in the sentences, there are no words as disaster or disaster issues. So I thought it's better to add disaster issues in green colored portion. So I'll read this. Science is the greatest collaborative endeavor. It contributes to ensuring a longer and healthier life, including disaster management issues or something like that. It monitors our health, provides medicine to cure our diseases, alleviates aches and pains, helps us to provide water for our basic needs, including our food, provides energy, and makes life more fun, including sports, music, entertainment, and the latest communication technology. Last but not least, it nourishes our spirit. Science generates solutions for everyday life and helps us to answer the great mysteries of the universe, including disaster issues. In other words, science is one of the most important channels of knowledge. It has a specific role as well as a variety of functions for the benefit of our society, creating new knowledge, improving education, and increasing the quality of our lives. Science must respond to social needs and global challenges. Public understanding and engagement with science and citizen participation, including through the popularization of science, are essential to equip citizens to make informed personal and professional choices. Government needs to make decisions based on quality scientific information on issues such as health and agriculture, including disaster issues, and parliaments need to legislate on societal issues which necessitate the latest scientific knowledge. National governments need to understand the science behind major global challenges such as climate change, ocean health, biodiversity loss, and freshwater security, as well as disaster issues. To face sustainable development challenges, governments and citizens alike must understand the language of science and must become scientifically literate. So here I put facilitator is necessary because we need somebody who make people become scientifically literate. On the other hand, scientists must understand the problems such as disaster issues the policymakers face and endeavor to make the results of their research relevant and comprehensive to society. Challenges today cut across the traditional boundaries of disciplines. So interdisciplinary approach is very necessary and stretch across the life cycle of innovation, from research to knowledge development and its application. Science, technology, and innovation must drive our pursuit of more equitable and sustainable development. So this is a description given in the website of the UNESCO. Next, please. So Sendai framework has 4 priority actions: understanding disaster risk and strengthening disaster risk governance to manage disaster risk, and investing in disaster risk reduction for resilience, and enhancing preparedness for effective response and to build back better in recovery, rehabilitation, and reconstruction. Next, please. Every year in January, a World Economic Forum is held. And this says the top 10 global risks for 2019. And you can see top 10 in terms of likelihood. And the yellow colored arrows shows that the items are disaster related. In terms of likelihood, extreme weather events, failure of climate change mitigation and adaptation, and natural disasters are ranked as number 3. And number 6, man-made environmental disasters. Number 8, biodiversity loss and ecosystem collapse. And in terms of impact, number 2, failure of climate change mitigation and adaptation. Number 3, extreme weather events. Number 5, natural disasters. Number 6, biodiversity loss and ecosystem collapse. Number 9, man-made environmental disasters. This was at the beginning of the year 2019. So the infectious diseases is ranked as number 10. Number 10 in terms of impact was spread of infectious disease. So next, please. And this shows the change of top 5 global risks, 2009 to 2019. The upper portion shows the global risks in terms of likelihood, and the lower portion shows the global risks, top 5 global risks in terms of impact. And before, you can see blue-colored rectangulars. Blue-colored ones are economics. This is a World Economic Forum. So economists were very much interested in the economic topics. But recently, green-colored ones and the orange-colored and the purple-colored ones are increasing. So economists have begun to recognize the importance of environmental and technological issues, hence interdisciplinary approach. Next, please. So this is the scattergram in terms of livelihood, x-axis, and the impacts y-axis, and the environmental issues are highly ranked in terms of likelihood and impact both. Next, please. And for the year 2021, top ranks. Number 1 was infectious diseases, so COVID-19. And in terms of likelihood, number 4 was infectious disease, COVID-19. But you can see some others are disaster related. Many of them are disaster related. Next, please. So global risks were something like this, and this chart was proposed at the expression of interest for ICOE, which was submitted in June or July to IRDR headquarters, and this was made by Professor Hayashi, and he related and categorized SDGs with disaster risk reduction and climate change adaptation. So this chart shows the importance of coherence among disaster risk reduction, climate change adaptation, and sustainable development. Next, please. And my school, Graduate School of Human Survivability Studies in Kyoto University, is dealing with various kinds of research fields. So there are medical, life science, informatics, engineering, agriculture, science, economics, law, and humanities. And so far, each field are very much intensified or deepened. However, we need integration to solve problems in the world. So human survivability studies are concerned with the survival of individuals, communities, and industrial societal systems, as well as on their future development. So our school is going to integrate by interdisciplinary approach to solve global issues. Next, please. And there are many disciplines in science and technology, and interdisciplinary approach is very important. And the science and technology outcomes should be applied to practice. This is transdisciplinary, and the practice will feedback to the science and technology, and the science and technology and the practice will be developed. In this interdisciplinary, transdisciplinary approach, we need capacity building of the societies and education at any levels. Who will do it? Capacity building and education. And in that case, I think a facilitator is necessary, and the common database or knowledge base is necessary. Online system for sustainability and resilience is necessary. Next, please. Japan have disaster resilience partners established in 2019, I already mentioned, and these 15 organizations which are interested in disaster issues collaborating each other in the framework of this Japan Hub, which is called JHOP for short. Next, please. And JHOP and its network with various kinds of organizations and networks indicated in this chart, which was also proposed by in the expression of interest for ICOE. Next, please. And Professor Koike's paper also showed the information infrastructure for nations synthesis on disaster risk reduction. So red-colored one is national platform. And the national platform should have some linkage with science and technology community and stakeholders. And we need some country portal and the international portal shown in yellow colored. And such portals are the focal points of each country and the international activities. And this kind of information infrastructure is so very important to promote disaster risk reduction activities. Next, please. And in Japan, this Disaster Countermeasures Basic Act was established in 1961, immediately after a huge typhoon event, Ise-1 typhoon event, and Disaster Countermeasures Basic Act, for short, DCBA, not ABCD, DCBA. DCBA includes 8 chapters, as indicated here. Next, please. And this is the time horizon showing the number of deaths and missing persons caused by natural disasters. In 1959, there was Ise-1 typhoon, which killed more than 5,000 people. And the DCBA was established in the year 1961. And after that, the natural hazards damages dramatically decreased because of this act. But not only this, but also public works investment for disaster management facilities. And in the year 1995, there was a Kobe earthquake. And in 2011, Tohoku earthquake and tsunami took place. So this is a history of Japanese natural hazards. Next, please. And the DCBA says structure of basic disaster management plan, something like this. And there are countermeasures for natural disasters, as well as countermeasures for accident disasters. And we should cope with those disasters. And to cope with those various kinds of disasters, we need common database or knowledge base, which will be the online synthesis system for sustainability and resilience. And national government, local government, and residents should cooperate for disaster risk reduction. But there is a gap between government and residents. So facilitator is necessary. Next, please. And there are hierarchical system, a national level and prefecture level and municipal level and residence level. And there are gaps between a prefecture level, governmental level, and the municipal level. And there is also a gap between municipal level and residential level. So to overcome these gaps, facilitators are necessary. And the common database or knowledge database is necessary. Next, please. In Japan, there is a kind of certified title called Bosai-shi, which may be translated into English as disaster managers. In Japan, already registered disaster managers are more than 200,000 people. These more than 200,000 people have a certificate of disaster manager in Japan. They could be qualified facilitators. So far, we have no contact with those people, but those people are potential facilitator. Example. Next, please. TechForce, Ministry of Land Infrastructure, Transport, and Tourism, dispatch experts to disaster sites immediately after the event to take place. So those people are experts, but they may do roles of facilitators, I guess, but I don't know how they can behave as a facilitators, but they are actually technician or disaster experts. So those people are also potential facilitators, I think. Next, please. Okay, thank you very much. Further details of OSSSR and the facilitator will be given by my colleagues, Professor Koike, Professor Hayashi, Professor Tamura, Professor Kawasaki, etc. Thank you very much for your kind attention.
Questions?
Hi, I have a question. Okay, hi, my name is Suzila from Malaysia. So basically, it was very interesting topic presented by Mr. Kawo Takara. But when I just wanted to ask about one question, which is when you mentioned that there are several types of disaster, has been occurred in Japan. So you have snow disaster, you have forest disaster, and so on. So after that, in the next slide, you mentioned about the disaster manager. So what I understand is the disaster manager is the one that can give the information or consultation about any type of disaster. So my question is there specific disaster manager for each of the type of disaster, or only one disaster manager that would become a consultant or to all type of the disaster in Japan? Can you explain more, Mr. Kaoru? Thank you.
Yes, disaster managers, I said, is officially called as Bosaishi in Japan. This is not a national title. This is a title given by some organization, and they promote such people who are very much interested in disaster issues. And many people are the general public or engineers, or I'm not sure the composition of the more than 200,000 people, but they are very much interested in disaster issues. And some of them are expert in some specific areas, but others are just knowing how to evacuate or how to manage emergency situations in general. So I cannot say how many people are earthquake experts, how many people are flood experts, but this kind of system is already existing in Japan. But so far, we don't know much about such disaster managers' activities. However, I believe they are potential facilitators. And there are thousands of people in each prefecture. So each prefecture, they may promote some activities for disaster risk reduction. So far, it is not apparent, but I hope, or I believe those people may have chance to do their roles as a facilitator.
Takara-sensei, I have one question.
Yes, please.
Yeah, thanks for your sharing. Look like we need facilitator at the different level, no matter in government, even in the field. But how we have the good system to provide good knowledge to individual facilitator and talk to the right people, and how we make sure we have transfer, how we can have a system make sure we can transfer good knowledge to different facilitator, and those wording by the facilitator will take effect. So how Japan deal with kind of the system to raise the good facilitator with the maybe same concept to enhance society resilience. Thank you.
Yeah, it's a good point, and we recommend facilitators. I mean, we recommend it is very necessary to have many facilitators. But how to educate, how to nurture, how to grow such a facilitator is a very important problem. We may have some lecture series to many peoples, but the time and the locations are very limited. So we need some mechanism, constantly educate people as a facilitator. So far, we have no idea what kind of seminars or schools or educational systems. I don't know. But one idea is to recommend people to be disaster manager, Bosaishi. Then they can be educated by such Bosaishi system. So this may be one idea, but I'm not sure it is effective or not. Thank you very much.
Thank you.
And thanks, Dr. Takara. And because of the time limitation, we probably will need to move to our next topic. And if you have any question or things, your ideas, you can leave them in the chat box, and we will collect them all together to the first day. We can all discuss the very freely in the first day. And sorry that I forgot to do the introduction to Dr. Takara. Dr. Takara is a professor of Kyoto University, and as you can see that he is a very experienced and senior contributor to international DR programs. And thank you for your the overview of the OSS system and why it is needed, and in a very also especially in a historical perspective, and really learned a lot from it. Thank you.
Thank you very much.
And our next topic will be brought by Dr. Professor Toshio Koike.
Do we have a 10 minutes break in between?
We didn't have the 10 minutes break in between, but if you want, we can arrange could we make it short in 5 minutes? And do you think it's okay?
I think let's have a 5 minutes. Yeah.
Okay. Okay, so let's have a 5 minutes break. And so we can come back at in 15 from probably in 5 minutes. And next topic we will talk about the limitations. Okay, so thank you. I'll see you later.
Yeah.
This is Toshio Koike. Can I try to share my screen as a test? Is it okay now during the display?
Sure. Yes, please.
Sorry for this. Can you see my screen?
Yes, very clear.
Very clear?
Yes.
Okay. So I will use my screen. Okay.
Okay. Thank you.
Thank
so
you.
we will start in about 4 minutes.
Yes. Thank you.
Hello, is everyone here? Because our time is a little bit over, so I think we should speed up.
So I think the system is back. So I can see Koike Sensei on screen now.
Yes, I can see Wei-Shen-san.
Yeah, I think due to some the internet problem, look like
Okay.
we
Okay.
temporarily lost some the lecture and the participant for a while.
Oh,
Yeah.
okay.
Yeah, because I see the signal of the internet unstable on some of their screen. Yes, Jian Chen is back. Yeah, this is sometimes the WebEx has kind of issue. Suddenly
Yeah.
it might slow down a little bit without any reason.
Yeah.
Koike Sensei, sorry, for some reason we cannot host a Zoom meeting.
I suppose the player is bad.
We can join Zoom meeting, but we cannot host any official meeting by Zoom. That is not kind of limit.
Yeah, that is the also the same reason which we cannot why we cannot use the Zoom.
So currently, I think a lot, especially meeting in the USA will prefer using Teams, Microsoft Teams. Yunxian, you are back now.
Oh, I'm so sorry. I don't know what is going on.
It's okay.
Bandwidth problem. Yeah, bandwidth problem.
Okay, so I'm so sorry. I didn't even know when I was, stopped. And so, Dr. Toshio Koike is a very experienced and executive director of the International Center of Water Hazard and Risk Management. And I think he is, has a lot of experience to share. And so please, Dr. Koike.
Okay, thank you very much for your introduction. And can I share my okay, and here. Can you see my screen? Okay.
Yes.
So the Professor Hayashi requested me to offer the lecture on the limitation of the disaster prevention need for resilience, especially focusing on disaster risk reduction and climate change adaptation, including the Sendai framework. So that is my topic. And firstly, yeah, I'm a climate and water person, different from the Professor Hayashi's the discipline, and very close to the Professor Takara's discipline. And with regard to the overall losses of the natural loss event, the worldwide, the number of the event of the geophysical event, the earthquake, tsunami, the number itself is not changed. So apparently, but the water-related disaster, flood, the cyclone, and drought has been increasing by more than 3 times since the 1980. And with regard to the economic losses also are increasing. So this is closely related to the climate change. So basically, is the climate changing? To respond to this basic question, IPCC has been working more than 30 years. Yes. And at its fourth assessment report, which was published in 2007, IPCC says warming of the climate system is unequivocal. Professor Hayashi mentioned that he doesn't like the English. I don't like English. As a member of the IPCC assessment report force, the working group 1, we try to this English words to Japanese language. It's a very, very difficult for us. And we identify one, the Japanese expression. Anyway, based on the various data sets, working group 1 for science basis declared warming of the climate system is unequivocal. This was the first expression which was used by IPCC. And 7 years later, IPCC assessment report 5th was developed by including Arctic summer sea ice and also the climate changing in the global average upper ocean heat content. assessment report fifth also says warming of the climate system is unequivocal. Same sentence was used after 7 years. So in that case, what changes the climate? IPCC assessment report fourth, based on the numerical simulation since the 1910 to 2000, by using the 19 climate centers computational power, the result expressed by this pink line in each continent. And in cooperation with 5 climate centers computational power, we calculated under the assumption if the same concentration of the greenhouse gases as observed value in 1910, what kind of the change of the temperature in the world? That is expressed by blue band. And the thick line was the actual observed data set. So then, assessment report fourth mentioned it is very likely this change due to the observed increase in anthropogenic greenhouse gas concentration. So this is the conclusion in 2007. Very likely mean more than the 90% of the climate model output says the same result. 7 years later, assessment report fifth, by adding the Arctic sea ice and the upper ocean heat content, it says it is extremely likely by the anthropogenic increase in the greenhouse gas concentration and other anthropogenic forcing together cause this change. Extreme likely mentioned means that the more than 95% of the consistency. So in this way, we increase the confidence of the reason of the climate change. And just after our assessment report fourth in 2007, IPCC was awarded as a Nobel Peace Prize. This is a Nobel Peace Prize. I was really proud of one of my contribution to the assessment report fifth, in the science part. That is my great pleasure. And the assessment report 6, working group 1 for science was published August in this year. In the 6th report, they say it is unequivocal that the human influence was warmed the atmosphere, ocean, and land. Widespread and rapid change in the atmosphere, ocean, cryosphere, and biosphere have occurred. So this is the reason. So this is the expression. So unequivocal was used for the climate system warming and how much greenhouse gas emission effect and how much the sulfur dioxide and also nitrogen oxides cooling impact, and then this is simulated the contribution of the human beings to the global warming. This is observed. So this is based on this result, the 6th report says unequivocal the change of the global warming, the changes of the climate system, and also that was caused by human beings. This is the scientific the evidence. So in that case, why the water-related disaster increase? You know the global warming, that is a greenhouse gas effect. Sunshine heated up the Earth's surface, and according to the surface temperature, long-wave radiation is emitted upward, and this long-wave radiation, the infrared radiation, is absorbed by greenhouse gases. Greenhouse gases, the concentration is higher in the lower atmosphere. That's why the lower atmosphere is warmed more, and then downward long-wave radiation emitted. So then the land surface heated up more. Then the convection activity is accelerated, and troposphere is mixed more. So then all of the troposphere is warmed up. This radiation and convection equilibrium is a mechanism of the global warming. So then associated with this accelerated convection activity from the wide area, warmed and humid air mass is converged in a narrower place and uplifted, and a heavier rainfall happened in a narrower place. This is the background of the phenomena of the heavier rainfall event happened more often. This was developed by whom? Shukuro Manabe. That is, he got the Nobel Prize in this year. This radiation convection equilibrium theory itself was developed by him in 1960s, but when he received the Nobel Prize, this is the NHK TV interview on the day. I got this screenshot, and he says, flood occurred more often. That is his first word. I myself, I was learned from him so long, and then I was much happy to hear this great news. Anyway, in this mechanism, the heavier rainfall happened in a narrower area more often. So then the result was summarized in this table, assessment report 4th and assessment report 5th, as I mentioned. And in between, we published a special report on extremes in 2010. So the assessment report 4th, the heavier rainfall event will happen very likely. And SREX also says the likely over many areas. And assessment report 5th says very likely over most of the mid-latitude land masses and over wet tropical region. So in this way, we got a more sophisticated, more confident result of our projection. So associated with this changes, this is the human loss event worldwide, not only the water-related disaster, but the human loss occurs. The more than 80% of the human loss occurs in the lower middle and low-income countries. With regard to the economic loss, almost the 3/4 occurred in high and upper middle income countries, actually. But the ratio of the economic loss to the GDP, lower income and lower middle income countries, the economic loss relative to GDP is much higher than the upper middle and high income countries. Then the 2030 agenda says, we are determined to take the bold and transformative step which are urgently needed to shift the world onto a sustainable and resilient path. So in this way, the sustainability and the resilience should be considered simultaneously. In the history of the sustainable development, started on the Stockholm the conference there in 1972. The initial discussion is controlled by North to South problem, and the solution was the sustainable development. This idea was developed the Brundtland, the Commission statement in 1987. So the sustainable development discussion on sustainable development has a long history with the North to South conflict problem. On the other hand, the disaster risk reduction started in the decade, the international decade for natural disaster reduction, 1990s, and 3 conferences were held in Japan. And this idea of the resilience was introduced in the Kobe conference, and at the Sendai conference, there this idea on resilience was emphasized. So the terminology of the disaster was the in Yokohama the disaster prevention, in Kobe disaster risk reduction, and in Sendai the disaster resilience. In this way, the wordings were changed. So, but the background is different, but we need to consider these two simultaneously. So, as Takara Sensei introduced the 2030 agenda, identified the 17 goals. This idea's background come from the Professor Hayashi, and these 4 goals are related to the quality of life. They are supported by water, food, energy nexus. And these quality of life and water, food, energy nexus are closely related to environmental concern and built environment. And they all are closely related to the social system, including the gender equality and equality, gender and then inequality and the peace. So under this, based on the consideration of this interlinkage, water-related disaster intensified climate change occurred. The effect that such event affect the built environment and environmental concern and water directly, but it's propagate to the water, food, energy nexus and the quality of life. At the end, social system was damaged. So we need to consider that these interlinkage related to Sustainable Development Goals and Paris Agreement and the Sendai framework. So in the last year, we have still now we have under the COVID-19 pandemic. This is a health issue, but this we understand this cascading the risk emerge, and it's affect our society beyond the boundary in space and time. So how should humanity survive such risks and live with them in a sustainable way? That is our fundamental question. So in 2015, this is a really memorial year for human beings. In March, we have a Sendai framework. In September, we got the 2030 agenda, and sustainable development goals were identified, and Paris Agreement in December. So we are requested to take a concerted action. So according to the Sendai framework, reducing the current risk and preventing the future risk and adaptation recovery, then we can build the resilience that is the path to the sustainable development. For that purpose, we need to improve our understanding. We need to strengthen the governance. We need to encourage investment activity, and we need to implement early warning and build back better. These four are the key priority defined by Sendai framework. So this is the framework, and then with regard to the water related disaster world, as I belong to the ICHAM. ICHAM is the International Center for Water Hazard Risk Management, under auspices of UNESCO. And we cooperate with UNESCO and other United Nations organization at the United Nations, and then we developed the principle to address these water-related disaster. That is based on the data integration on the damage, hazard, and socioeconomic. We need to strengthen our capacity for integrated risk assessment from the past to future, including the social change and the climate change by identification, monitoring, and prediction capability to increased. And then we can contribute to the policy making and community of practice. For that purpose, data archiving, model development, and social benefit creation through the interdisciplinary and transdisciplinary cooperation. That is to promote this kind of activity, we need to establish a platform. And this platform includes a capacity building component. That is our proposal based on the discussions, series of discussions just after the three key agenda, the Sendai, SDG, and Paris in 2015. So, and then high-level panel on water organized by UN Secretary General and President of World Bank Group by inviting the 11 head of states and also the one special advisor. And they discussed and developed the outcome document that is making every drop count. In this high-level document, they identify resilient economies and societies and disaster risk reduction. In this chapter, they identify platform on water resilience and disaster among all stakeholders should be formulated in countries to facilitate dialogue and scale up the community-based practice. So according to this high-level statement, we are now working together with various countries. The data integration analysis system, the archive, the data, then the integration for flood forecasting and early warning, climate change impact assessment, and economic assessment, and agricultural productivity. And this information should be passed to the society for the investment direction, decision, and the policy and decision making, and the local practice. So for that purpose, not only the hazard data, but also damage data and socioeconomic data is needed. And this integrated knowledge should be passed to the society through the capacity development. So this, the green, red part is we call the online census system. And for sustainability and resilience, and green part, the role of the green part is facilitated. We need to foster the facilitators. So the in Africa, we developed this OSS system and provide the training for trainers, training for facilitators. And in Asia, my colleague, Dr. Miyamoto, will introduce the case of the Philippines. And in addition, Indonesia and Sri Lanka, we are now applying. So the what is the key? So this is also the closely related to the Professor Hayashi's information. So just happened after this happened, the society function reduced, and gradually it recovered. We need to reduce this area, the risk reduction as much as possible, as much as possible, and by evacuation we can absorb the shock, and then quick rescue and rehabilitation recovery. We can reduce the risk in this way, and Build Back Better defined by Sendai framework. We can get back better stage, and of course the preparedness there can reduce the risk dramatically. The player of this activity is the residents and the community and companies and the national and local government. So they to provide the useful information for them. We need to share the scientific information or socio-economical survey and statistics. So for that purpose, we need some data and information integration system that is called as an online census system, as Professor Takara introduced, and so a kind of the interpreter there. We need facilitate as Professor Takara introduced. Then we can share this information with actual player for their action, and some accumulated information can be used for planning and training. And also this accumulated information can be used for making a design of the infrastructure and the land use planning and management. This is a preparedness for disaster. And at the same time, this is the activity for economic and social development. So in this way, we can contribute to the sustainable development and disaster resilience in the same way. So that is our strategy. I prepared the other two slides, but this is closely related to my topic at the next session, the DIAS. So I would stop here. Thank you very much.
Thank you, Professor Koike, and thank you for the very efficient in the time management. And so, if you have any, if the participants you have any questions, you can leave them in the chat box to see if we have time. If we don't have time today, it's no problem. We have the day 4. We have a lot of time to discuss about the topics here. And please also check. I will ask you to see there is a check-in form link in the chat box, and would you please sign up there? And we have, because we want to speed up, so can we make the rest time from 10 minutes to 5 minutes also in this break? Is it okay with you? Okay, so let's come back in 5 minutes. Is that okay? Okay, I'll see you later in 5 minutes.
Very wonderful speech by Professor Koike. I think you explained very good sketch about combine every discipline in one slide. Wow.
But the original point they come from, many original point come from Professor Hayashi.
So I said today also a learning process to me, because very comprehensive diagram to explain so many phenomena just in one slide. Wow. Wow, very meaningful and informative too.
Thank you very much.
I also appreciate your work, how to make the climate change more for the construction side. Especially you mentioned you collaborate with the levee design, how to improve levee design in consideration of climate change. I think that's also a great work done by you and your team, who work with the hydrologists to make the climate change adaptation as the real construction work. I think that's also the good example. I hope someday I can hear again about that part too.
Okay, thank you very much. Yeah, unfortunately, that water disaster, the number and the intensity are increasing. We have to work more to reduce as much as possible. Yeah.
You know, like Taiwan, before this June, we have the record drought.
Yeah.
But
So
suddenly,
in Japan, everyone considers the flood. But I mentioned the drought is also very critical the disaster in Japan also. Because why I started this kind of water related science in the university when I was the undergraduate course, my hometown, Fukuoka, Kyushu Island, suffer very serious flood. This is a large, very serious drought. This is a historical largest drought after the Second World War of Japan. So the drought is my first target, but nowadays the flood is much more often.
You also told me once you stayed in Tibet for a couple of times to observe the rain cloud formulation there, and how the Indian monsoon to begin. Also the great job. You spend a lot of time there to observe in very severe condition.
Yeah, our scientific capacity of the monsoon, how to say, how to express the monsoon numerically by the general circulation model. That's scientific contribution is very, very important. So then we can project the impact of the climate change on monsoon. That is critically important in Asia.
Especially through your personal observation and put into theoretical model.
Yeah.
That is awesome job done by you.
林先生、ミュートみたいです。
スライド見えてますでしょうか? Can you see my slide?
Yes.
Okay. Thank you.
It's very clear. Okay, so very short break is over now. So I want to introduce Dr. Hayashi, who is the president of NIED, and he's also a professor of emeritus of Kyoto University, and who is also the very important the force behind this program. And so please, Dr. Haruo Hayashi, please give us your talk today.
Okay. Thank you very much. Let me talk about the nation's census reporting and the online census system, how these two are related in our mind. Okay. I don't know how to start. Okay. As Professor Takara introduced, integrated research on disaster reduction, IRDR, has started in 2008. Next year, Japan National Committee was established as one of the committee of Science Council of Japan. And then Japan National Committee held a conference named Tokyo Conference on International Study for Disaster Risk Reduction and Resilience. The statement we compiled was used as one of the bases for Sendai framework for disaster risk reduction. 2 years later, in 2017, we held another international conference entitled as Global Forum on Science and Technology for Disaster Resilience 2017. It was a 3-day conference, I remember. Then we reached the conference reached two conclusions. The first conclusion was guidelines for strengthening disaster risk reduction national platforms and coordination mechanisms through enhanced contribution of science and technology. We need to create this. That's the first conclusion. And the second conclusion was we also need a periodic synthesis report on the state of science and technology for reducing disaster risk. So that's the initial impetus for us to think about online census system. At that time, a census report come up like every couple of years from various initiatives. Future Earth published some documents. IRDR also have their own censuses. UNISDR STAC also have another thing. And when we had a meeting, European Commission Disaster Risk Management Knowledge Center published almost 600-page censuses. They call Science for Disaster Risk Management 2017. 2017. And then 3 years later, they published another one, and then it became more than close to 700 pages. And this is very, very impressive, thorough, and specific sets of information. And by comparing these two so-called synthesis report, we can see that like somewhat standardized content structure of disaster risk management. They started with the summary of the current status of disaster risk management and then policy framework, which is corresponded with the Sendai Framework Priority Action 1. And then elaborate the risk management cycle. Again, that part of understanding risks. And then in the next chapter, they devote elaborated explanation or description of disaster risk, hazard by hazard. And then followed by impact analysis or risk assessment. And then fifth, up to that point is the elaboration of understanding risk, used as one of the priority actions in Sendai framework. And then they talk about how the science and technology communicate the disaster risk to wider audiences. And that's somehow relevant with the governance issues. And then they start talking about how they manage the disaster risks and end up with the future challenge or future pictures. And then if I look at this, they only covers 2 priority actions, priority 1, priority 2. They are not so interested in terms of pages on investment or Build Back Better. And then surprisingly, if I compare these two syntheses, they have a very different title of the chapters. And then only common elements are the 3 points I put it down at the bottom. In each volume, they emphasize that the multi-hazard approach, and they emphasize also a disaster management cycle approach. And then they also emphasize the mainstreaming of disaster risk reduction as a very important element. But as of these, a synthesis is concerned, all of them are English-based synthesis, and they are pretty much rely on academic achievements. 600 page long and 700 page long. So how many people could read through those many pages? Are they clear, or are they decisive, or are they action oriented, or are they participatory? And then in addition, I'm wondering how these volumes have been edited, or what kind of process they took. I believe they are very fair and rational processes for that, for editing a synthesis. But that's seems to me it's very, very irrelevant to the disasters I have been observing or participating. So it's very, very academic in nature and very, very nice as a reading, but I'm not so convinced by those good, nice words as a basis for my own action. At the same time, as both Takara sensei and Koike sensei mentioned, 3 UN conferences have been held in Japan. And then for the third conference, the importance of national initiative have been clearly described in the Sendai framework. So if I follow, or if I follow the 2017 conclusions, it is very important for IRDF Japan National Committee to promote the nation's synthesis. In other words, that how one nation deals with the disaster risk reduction, to summarize the state of affairs, state of technologies, and the problem nations facing. All those things should be packed together and clearly described in the census report. And if so, that at that time, this is my memo at the 2017 conference, we need some kind of structures to put the various kinds of information together in reference to a Sendai framework. That was the first zero version of online synthesis system. Then this kind of editorial work may be done in every couple of years, but we at that time discussed, since we are now in the world of internet, if we could use the internet, we don't have to publish the very thick censuses every couple of years. We may compile the website or at any time to suit our own purpose, to integrate the lessons available from the world. So that was the initial idea. Online census system was brought up. So as a census report, we may need to publish English-based a document, but we thought it is more important to have the basis for censuses. This is not a periodical thing. It could be like a ubiquitous thing, so that we can use every day for our own purposes. And then this basis for synthesis should be using our own mother tongue. And then so at the same time, we can contribute ourselves to this kind of a system, and then reflect various or diverse stakeholders, not just only academicians, but real practitioners or politicians or the people from different countries, and all those diversity should be welcomed. And then we started really think about census system. And since every disaster is local and unique, so safe community is also local and unique. So it is important to tailor the solution for each community, and then trickle-down approach may not be enough or appropriate because that, as example, in Japan, National Secretariat for Disaster Risk Reduction may not be so strong, or rather it tend to be weak, because the disaster risk reduction is not the number one national priorities. So that we need to wide or open up the participation from various stakeholders, so that community level participation may be very, very important. And then the idea of facilitators came into the picture. So the facilitator will connect those a system of knowledge and local problems. And if we could have the system to help facilitators to have more capability and more tools to solve local problems. And that's a kind of orientation we started to explore under the OSS project. So now we call OSS and facilitator. So online synthesis system can be defined as an internet-based system for collecting, analyzing, publishing, reanalyzing, critiquing, and reusing data and information for improving disaster resilience. The feature might be all-hazard approach, covers all phases of disaster management, and register data or information in the form of either file or of web link, and support activities to promote open science. And the strategy, we work like organizing wide science and technology communities. And not just a few people do this thing, but many people will collaborate with each other. And then start with the small thing. So the small start is very important. And then hope to upgrade in the future based on users' needs. And we wanted to do the implement pilot studies and then get the feedback from user community. That's an idea we had around 2018 or 19. And then we started to collect various contents, like photos and movies, academic journals and database and SNS data and case studies and oral histories and various kinds of apps, or the dictionary, which define the keywords. And then we tried to put them onto one site, and we named it as Literacy Hub. And this will help us to search the right website or file for our own interest by searching keyword. And background of this site, we started to provide the metadata to classify these inputs. And we put types of information, and we try to identify what kind of risks we are talking about, what kind of disaster management phase we are interested in, what kind of users we have in our mind, and the basic reference information. And we created this kind of classification scheme, but it was not so happy to have this because it seems something is not complete. We still have the feeling of incompleteness by doing this. And then we start using a very different style of classification, which will be elaborated tomorrow night, second night by Professor Inoguchi. And you wait and see. And then let me talk about a little bit about how online system and the facilitators connect. As a Sendai framework defines, it is important to have a national strategy approach. But as indicated in Japan, I personally feel it is not so enough. And because as I mentioned earlier, disaster risk reduction may not be the #1 priority as a national priority. So that the national secretary, if national secretary is weak, national strategy may not be so effectively implemented to a local governments or business sectors or civil societies. So this is basically a trickle-down approach. A nation do something, and then community, individuals, and organizations will be benefited later. But if we could have the facilitator with OSS and directly go into a community or deals with the individuals or work with the organizations, they directly empower these stakeholders. So this is another approach based on national government initiative or national secretariat initiative, but it's more like target focused and maybe more effective. So that the facilitator will be connect external resources with a local community, and they also empower local community to be sustainable by focusing on the disaster risk reduction. And they will provide a proper knowledge, experience, and tools for disaster risk reduction, help local leaders to learn a standardized but effective way to improve their disaster resilience. And then also help local leaders to implement what he or she learned. And then share the experiences and lessons obtained from that locality to the other areas. And those are the expected roles of facilitators. So in practice, the facilitator may have 7 functions to take, and this portion will be explained by Professor Tamura on day 3. And then with those effective facilitators supported by OSS, the community itself or individual themselves, or organization itself may be empowered, and that also eventually makes national government stronger by kind of a mutual support. That's a kind of a final image of the synthesis we have in our mind. And so those are the points. I missed the governance point, so it will be a modified letter. Then this is the typical slide we use in describing the relationship between facilitators and OSS. So we think the problem for disaster risk reduction locates at site where the people live. And OSS is a kind of a tool to help facilitators to work as a catalyst between integrated knowledge for disaster risk reduction and the local problems. By the use of internet, we could provide such information, systematic information to the local users through facilitators or directly. But this OSS is somewhat different from Google. As many people pointed out, Google cannot provide a new perspective. Google only reinforce the perspective the person already has, because they have to select the keyword to Google. And they have no idea to come up with unknown keywords. So they only use the keywords they already know, so that as a consequence, there is no new perspective will be available through Google. But OSS is a kind of a continuously growing a set of information concerning disaster risk reduction, so that OSS will provide unexpected such results that may hint the local users to come up with new perspectives, supported by the facilitators' involvement. And then this new solution, lessons from those new implementation will be fed back to OSS through facilitators. That's a strong portion of the continuous growing part of the OSS. And this, now we are trying to develop this kind of system in various contexts. On day 2, from 3 different perspectives, OSS will be introduced. It looks quite different because OSS is not the system. It's a system of systems for disaster risk reduction, so that it may looks different, but basically that all OSS system will help this picture to be implemented. That's how we started with the nation's reporting system to OSS and facilitator. Thank you very much for your attention.
Thank you, Professor Hayashi, for this comprehensive introduction. And also, because you have a little bit earlier close, we have 5 minutes. Is there anyone want to bring up some questions or discussions here?
Hi, Sensei.
Yes.
So, compared to traditional system, I think OSS should have more non-structured data than ever we have. So that would be very challenging thing, how to do the data mining through such unstructured data, especially we must produce some information for the facilitator.
My answer is ask Professor Inoguchi on day 2.
Okay.
Yeah. We started some classification scheme could be achieved by which everybody may agree upon, but that's impossible. that is my conclusion. So we aborted that kind of structural ideas. But thanks to ICT technology, they actually search every single word and then pick up keywords. I don't know how to do that, but Professor Inoguchi knows that. And then we go through some kind of concurrence or conjoint analysis type thing, so that we could detect how these two inputs relate with each other, and then could visualize on the 2D or 3D world. So that's a different setup, but that seems to me more natural, and then I don't have to kind of worry about those incomplete classification scheme.
Thank you.
Thank you. So yeah, when we started, we proposed like importance of an international committee for checking the ontology or classification scheme of those keywords. But after abandon the scheme, we could be more like a small in size in proceeding the project. No need for worldwide, but because of COVID, since this kind of online conference become very, very popular, so that we may now you could have an international committee for classification scheme. Yeah.
So thank you, Professor Hayashi. And so because so it's time for us to move to the next topic, and which will brought up by Dr. Xie. Dr. Xie is a professor in the computer-aided engineering division of the Department of Civil Engineering at National Taiwan University, and he is now also serving as a chairperson of the department. And so please, Dr. Xie, would love to hear from you.
Okay, can you hear me?
Sure.
Yes.
Okay, good. Yeah. So thanks for Weisen's invitation. Weisen asked me to introduce how Taiwan government is applying science and technology for disaster risk reduction. Within the scheme, I will show you how we also have some organization to facilitate things and how to synthesize the technologies application. So these are the outlines. First one, I would briefly introduce the disaster preparedness and response in Taiwan. And then I will introduce two programs that we have. Okay. So I don't know how many of the participants know about Taiwan. But since we have the pandemic, I think I found out that there are a lot more people now know about Taiwan, but more on the technological side. But I'm going to show you some about the related to the disaster. So this is Taiwan Island. You can see on the map that we have a high mountain areas in the middle part of Taiwan. And so over 70% of our land is in slope. And also we have a high concentration of population in urban area. And also we are at the conjunction of two places. So we have we are experiencing constant earthquake on the island. Last night we just have some, in Taipei City, we just feel some earthquake last night. And also we are under high risk of tropical cyclones, we call typhoon. The average number is about 3.6 per year. So those are the situation we are facing here in Taiwan. So in recent years, we have two severe disaster events. The first one is Moraco typhoon in 2009, and then in the subsequent years, you can see that we have this. Once we have typhoon, we may have the urban flood, debris flow, and landslide. And in 1999, we have a big earthquake called Chichi earthquake. And under that earthquake, we have many damage or collapse residential buildings in middle part of Taiwan, and also infrastructure damage, collapsed schools. Okay, yeah. Okay, so based on the maple crops in 2014, called extreme of absolute economic exposure, you can see that there are 5 countries. This is as in the extreme categories, and Taiwan is in the middle of those 5. So that's the situation, and you can see Japan is also, India is also in Asia area, China, and I want to use this as an example because Typhoon Morak actually, you can say that impact what we have been doing for applying science and technology for disaster risk reduction. So it marks kind of marks an error. So we change the strategy and we do something differently. So you can see the typhoon is actually passing through the northern part of Taiwan, but it brings a lot of rainfalls. and also a very intensive rainfall. So you can see on the map, although the Taiwan is passing through the middle and up northern part of Taiwan, but the hard hit areas actually in the middle and southern part of Taiwan, especially in the southern part of Taiwan. And you can see there's a death toll that's very high because one of the village was fully buried under the landslide. So let me show you rainfall. You can see the duration of the rainfall. It lasts for over 24 hours with high intensity. And as I mentioned earlier, that because we have mountain in the middle and it's really sloppy, so it causes a lot of landslides for us. And so what we have learned from the Typhoon Morak in 2009, we found out at that time, we found that a lot of government agencies at that time already have collected quite a lot of information and data. But it is still in the kind of too much or too little information situation at the emergency operations. We know that we need multiple sources and channels to acquire useful information for emergency operations. And also we need to have the system to integrate information. But on the Typhoon Morak, and then we found that we do have a lot of information, but they are not synthesized. And also they are not put into the right place or with the right integration for us to use at the emergency situation. Also, we are lacking of common operating picture to coordinate actions. So we found that we need to build up the potential risk map for planning, and also we need situation maps for operation. So we can have better decisive operations. And another issue is about when and how to make timely operations. So we need well-organized teams, and then we make decisions based on the evidence. And also we need better information sharing about the stakeholders, among the stakeholders or the team members to act timely and also effectively. So after some efforts, you can see that in the Socioeconomic Resilience Index 2013, while Taiwan is here, it's very tiny here, but you can see it's in green, it's called low risk. So we look at the factors that lead to low risk in Taiwan. Today I'm going to mainly talk about the application of science and technology and how we make the risk transparent to the public. And of course, we also have a well-organized legal framework established. And also we have active participation by private sector. There are a lot of NGOs, NPOs, community, and how to involve academia and professional group into the picture. Okay, now I'm going to introduce a program called Executive Yuan Program on Innovative Technology for Disaster Reduction Program. This is the history for this program. So you can see about 20 years ago, starting from 1998. And then we started a program called National Science and Technology Program for Hazards Mitigation. And then as I mentioned earlier, in 1999, we have the Chi earthquake. But we continue with this program that lays a foundation for disaster prevention research and technology development. Basically, in studying from this program, we try to integrate the get the academia involved to contribute the academic effort to do research for hazard mitigation. But then starting from 2007, we go into the second phase called strengthening disaster prevention and response technological R&D and operation implementation plan. Within this period, we try to strengthen applied research and implementation. So you can see up to this point, we are basically trying to apply research and try to implement the research outcomes into practice. But as I mentioned earlier, under Typhoon Morak, we found that, okay, we do have a lot of research outcomes. And with all this research, a lot of our government agencies also have accumulated a lot of knowledge and collected a lot of useful information, but they are not integrated at that time. So based on what we have learned from Typhoon Morak, then starting from 2011, we started the program called Executive UN Program on Applied Science and Technology for Disaster Reduction, STDR for short. And starting from this program, you can see it's up to the Executive UN level. That means we have the higher government level for integration. And so we run the program for 2 phases. And currently we are in kind of the third phase. The name is changed a little bit, called Executive UN Program on Innovative Technology for Disaster Reduction. In the later slide, we use ITDR for short. And starting from the Executive UN on Applying Science and Technology for Disaster Reduction, the first thing we try to do is try to establish a disaster management integration platform to integrate the information that we have already collected and managed by different government agencies. And this is not an easy task to convince all the government agencies to release and share their information, and also try to understand how or what information they have can benefit to other government agencies, and also contribute to the disaster reduction of the country as a whole. And so we use an integration platform to gradually collect information and try to demonstrate how the integration can actually benefit everybody in the team. And then into the second phase, then we try to apply the integrated information and also promote interdisciplinary and transdisciplinary research on reducing the impact caused by the severe disaster event. And later on, we currently we are trying to establish an intelligent life for disaster resistance, and then we try to commercialize and industrialize some of the technology developed over the years, and also invite industry to contribute. So I would just quickly go through what I just say, but in text. So in the first phase, that for the starting from 2011 to 2018, at that time we try to reinforce the horizontal information integration mechanism and to strengthen the integrated application of disaster reduction technologies. And we try to establish a disaster reduction web platform and enhance the exchange of big data. And to disclose the regions with high disaster risk potential and reduce the impact of the disaster. The fourth one is to advance the technology development in disaster prevention and response, especially on its commercialization and industrialization. So over the period, we got 32 institutes and or agencies under 10 ministries involved and collaborate with us. So this is the program scheme. You can see at the very beginning, we have different type of issues. And then in the first phase of the program, the first 4 years, you can see all these topics more still fall into the professional silos. That is what related to the landslide, flood, the drought, and earthquake, and so on. And then into the second year, once we have more information integrated and also more interdisciplinary research involved, and then we started to target the issues as cross the boundaries of original silos. So we are looking at, for example, the issue related to the whole river regions, or we try to simulate the scenario and the mitigation technology for large-scale earthquake in urban area. So it's not just related to the earthquake engineering or structural engineering, but also related to social, economical, and also to other aspects of the disaster risk reduction. And on the top of this chart, you can see that we try to classify all these research efforts into 3 different categories. One is the data. So for the data type, that we more on how to collect useful data and to the right precision that can be used, can be applied, and to be the completeness of the data. And then there are other type of research working on the model. Those model will be applied on the data to support decision making or to generate simulation scenarios for decision making. And then there will be research related to the risk management type. And so this is the outcome after the first 8 years. You can see that we launched over the 8 years, we have more than 700 projects, and then more than 1,300 research outcomes. And these are the classification into the data, model, and management. So you can see different items. And also for research funded under this program, that we require that all the research outcome should be applicable within 3 to 5 years. So they need to have to work with the stakeholder, basically 1 or 2 government agencies, that they would, in 3 to 5 years, they would apply the research outcome into practice. And so you can see from the chart that we have some projects still in early research, outcomes still in early research stage, and some still in development. But for the mature and that apply one, those are the the outcome for those 8 years. And then the investment from the government is 5.4 billion NT dollar. And then the current phase, we call that innovative technology for disaster reduction. The objective is to improve the accessibility of disaster prevention information for users and to reinforce the operation and services in public and private sectors, to increase the value of disaster prevention industry and to build disaster resilient smart cities. And for now, there are 26 institutes and agencies under 8 ministries in the program. So this one kind of highlights that starting from the very beginning, we try to build the basics scientific research, and we use the result of that research, and then we started to integrate the information for disaster prevention. So we create a platform to share, to integrate and share the information, and also to support the disaster prevention industry, try to commercialize or industrialize some of the outcomes. And also we start to enhance the social services and advance and continue to advance research and technologies. So in the first 8 years, the stakeholders are mainly, or we are basically applying the science and technology to help the government agencies. But then at the end of that first 8 years and into the current stage, that we try to provide the research outcomes to not just the government agencies, but to share the result with non-government organization and even to some specific ethnic group and to the communities, and also definitely to the university and academia. Yeah. And then so in the past 2 years, these are the outcomes from the ITDR program. So you can see the same thing. We have the data model and the management. Yeah. So those are the outcomes. And the investment is 1.3 billion NT dollars. And just try to highlight some achievements. I think the nice thing we achieve in this program is that we through the integration and sharing of information, we really build a team of government agencies. They can work together for disaster risk reduction and also for the emergency response. And we also have the agencies like NCDR to facilitate the partnership and enhance the collaboration on disaster reduction and emergency response. Okay, and also we also bring together all the university research efforts. So the academia, they understand much better about the needs of disaster risk reduction, and they can align their research effort to help the country to prevent the disaster. And also that also help to educate our young generation to be much aware of the disaster we are facing, and also they are better equipped with the technologies that can help us to cope with the future disaster. this is just to give you a quick show on the disaster management information platform. On the platform, we have 6 main category disaster reduction topics, and we host. I think this data is a little bit outdated. I think currently should be more than 40 terabyte of open data that can be shared. Some to the public, some to among the government agencies, and some to the academia for doing further research. And a lot of sensing data, real-time monitoring data can be shown through the interface. So you can see, for example, on the left-hand side, lower part, this one is trying to show the water resources, how many. If you click into another layer, you can see all of the reservoirs water situation. Okay, and this is the current one that the portal that try to have all the research effort accumulated, and then you can find all the technical reports from the agencies or institute. And this portal has formed a good foundation for enabling integrated application of research outcome. And another effort we did is try to identify the region with high risk potential of natural disaster. And then we published the map so people have a better knowledge about how to prepare for potential disasters. And we also, since, if I remember correctly, that since 2018, we started to compile and publish disaster prevention manual. For example, for these years, we have 180 research output from the government agencies are selected for commercialization and industrialization. And we use this as a tool to encourage the industry to collaborate with the academia and to increase the added value of the technology. Okay, I will try to use the rest of the time to quickly tell you another program we have that is called Information Sharing and Integration between the central and local governments for disaster risk management. So you can see that across different regions or counties in Taiwan, each region has different natural characteristics. But if you look at the top 3 disasters, you can see a flood, debris flow, and earthquake. Those are the top 3 disasters among all the regions. But usually the central government, as I mentioned, we invested a lot of effort to build up the capacity for the central government to deal with the disaster. But the local government usually they don't have that much resources. So after we build up the capacity for the central government, the next stage is to build up, try to empower the local government, and then try to invite the local government to work closely with the central government for disaster risk reduction and also for the emergency response to the disaster. So basically, we try to again apply science and scientific research results for assisting the local government in disaster risk management, and then we try to invite the local research institute as a partner to host to help the local government to build up their capacities. So this can improve overall disaster prevention risk reduction capacity of the nation. So each region, they will have some university to work as a partner to help them to follow what we have done in the central government and to try to help the local government. So for emergency operation, of course, the central government will try to share the information with the local government and the vice versa. And then through this the program I mentioned, NCDR is the project facilitator. They try to run the program office and try to match the local research institutes and select the research institute to help the local government, and also provide some guidance, some frameworks that has already been successfully implemented by the central government, and shares some of the tools, the framework, the experiences, and then through this local research institute, and then help the local government to build up, collect, integrate their own data, and build up their tools, and then set up their own local government framework, and so on. So you can see from all these that NCDR actually visit all these local government and try to discuss with them to clarify what they need and how we can we can help them better to co-work and co-design on disaster risk reduction. And these are some other examples. You can see under certain disaster situation and how the central government and the local government, they work together as a team. Yeah, and information sharing is also very important. So in this program, we have 22 research institutes involved to help 17 local governments. That's all my talk. Thanks for your attention.
Thank you. Thank you for your talk. So, as a Taiwanese, I also learned a lot from this. So, is there? We probably have a couple of minutes. Is there anyone wants to ask questions regarding Dr. Xie's talk or Dr. Hayashi's talk? And
Hi, Sensei, something to say.
Okay. May I ask a very simple question?
Yes.
I'm wondering that the executive yuan is some kind of a name of the people, significant person, or I'm wondering why you put the executive yuan program.
Oh, that means that the program is part of, well, how to say that is because we Executive Yuan is the highest executive organization in Taiwan. Okay. So this program base is run in that highest level, not in the ministry. So it's above the ministry. So because then we have the committee over there. So through this program, then we can integrate the information sharing among our ministry. if it's only a program run by, say, MOST, the Ministry of Science and Technology, then other ministries say, okay, well, you are just at the same level as me. So why can you order me to do things, right?
Okay.
So although it's kind of powered by the Ministry of Science and Technology, but we need to raise the level, one level up to help coordinating and integrating. Yeah.
Okay. Sounds familiar.
Exactly.
Well, what
Actually,
do you want to
like
add?
cabinet
Yeah.
level.
Okay, thank you very much.
Okay, so thank you for all the speakers today. And because the time is late, and I know that it's pretty late for Dr. Hayashi's and people from other time zones. And so I've seen quite a lot discussions or questions from the chat box, and we will collect all these texts, and we will leave this into day 4, or probably we can pick some of them to discuss in day 2 or day 3. Okay, so I will keep. Yes.
Yuan, could you kind of distribute all the chat text to the participants, including lecturers,
Sure,
so that
no
we
problem.
could prepare?
Okay, and I will do some organization of the questions, and I will send it to all of you. Okay. So thank you, and because it's I think it's the end of today's program, and I want to thank you all for these efforts on this program and on the session day 1. And for the day after tomorrow, on Thursday, we will start at the same time, and we will also do the one more checking form for you to sign up. And so I think thank you all very much. So
okay. Bye-bye.
Bye-bye.
Good.
See you the
Bye.
day
Have a
after
good night.
tomorrow.
Yeah.
Have a
Okay.
good
See
night.
you
Have a
Thursday.
good evening, good night, and
Yeah.
Good
everything.
night.
Yeah.
Bye.
Bye.
Thank you very much.
Thank you all. 李老师，对不起，李老师，那个我应该会明天我就会把影片放到 YouTube， 今天的影片。
好。
然后对，因为我可能会再写信，再跟讲师们再做一次，就是确认这件事情，然后明天就会把它放上去。因为今天有些人有反映说他们那个就是有 miss 掉一部分没有听到这样。
对，是。
好，
辛苦啦，
大概
辛苦大家啦。
谢谢。
OK，好，
谢谢。
好，辛苦你啦。
不会。
好，就这样。
谢谢，拜拜。
好，
晚安，拜拜。哎，是我这边要按退出吗？那个录影要先结束吗？还是它会自动那个吗？